Welcome, Algebra 1. This is Section 4.2, Patterns and Linear Functions. The essential question is, what is the relationship between an independent variable and a dependent variable? Let's begin. So this chapter is kind of going a different place than we did last week. We have a goal here, and the goal is to kind of understand what a graph actually represents. And it's an equation. We graph some kind of equation with two variables, and it's a set of all possible solutions that are all plotted on the coordinate plane. So there's a lot going into that, but for the goal for this lesson right now, we just want to understand the relationship between two variables. So let's explain how these are related. So there's two types of variables when you're graphing. You're going to have an independent variable and a dependent variable. And the difference is, independence one, it's independent and it changes by itself. It's not affected by everything. It'll just keep getting bigger or smaller by itself on its own. A dependent will be changing based off of what the independent does. And this might take a while to kind of understand, but let's do some examples. So if I wanted to graph your age versus your height. Well, age, this would be the independent variable, because you grow older every year, 1 year older. It doesn't change. You don't grow 2 years older one time. You're always growing 1 year older, and every day is another day, and you're 1 day older. Well, your height is going to change. Like if you're a year older, next year you'll probably be a few inches. You might be an inch taller. And the next year, maybe only half inch taller. Sometimes you don't grow at all. Sometimes you grow half a foot, especially around your age. So this is going to be dependent on your age. So like when you're a little kid, it's really small, but as you get older, it's kind of going like this. Then boom, hit puberty and it goes crazy. And then at some point, you kind of plateau, maybe even shrink a little bit. Another example is the day of the year versus temperature outside. So the day of the year, it's going to change. You're always going to have the next year. Tomorrow is going to be the next day, and it's not going to change. Time's not going to stop. So this is going to be independent. See the pattern here? It's like time is always independent. It's not affected. But the temperature outside can be affected by what day of the year it is. If you're talking about it's the winter years, it's going to be really cold, and if it's the summer years, it can be really hot. So you might see a graph like in January, where it's kind of cold and it starts warming up in the spring and summer. It's going to be really hot in the summertime, then it goes back on down as we get close to winter. So that's what the temperature does. It changes, but it changes based off the day, and the day keeps going. So the temperature is what's dependent. Now, another thing is how much you study versus your grade. So the way this works, how much you study is independent, because how much you study is going to be independent because it affects what your grade is. So this is dependent. For example, if you don't study at all, your grade is going to be really low. If you study a lot, your grade is going to be really high. So how much you study affects the dependent variable, your grade. So let's do this another way. I have these figures that represent some relationship, and I want to represent that relationship between the two variables in a bunch of different ways. So, write this down and see what you can understand. We'll play around with this more this week in class. So, it's the number of rectangles versus the perimeter of the whole shape. So, for example, this first shape right here, the perimeter of the shape, well, if this side is 1 and this side is 6, so it's 6 plus 1 plus 6 on this side and another 1 on this side. So that perimeter would be 13. Now, in this shape, we have two rectangles next to each other. The next one's 3 and then 4. Well, the perimeter of the next shape is going to be 6 plus 1 plus 1. This will be 6. This will be 1 and 1. So that perimeter is going to be 6, 7, 8, 24, 6, 8, 14, 16. And they'll keep growing. So let's make a table to represent that. So I'm going to make a table of the number of rectangles, so I'll call this rectangles, versus perimeter. So in the number of rectangles, it will start off at 1. What's the perimeter? We said it added up to 13. Nope, it doesn't add up to 13, it adds up to 14. Didn't count right. Alright, when rectangles is 2, what's the perimeter? Well, 6, 12, 13, 14, 15, 16. When the rectangles are 3, what's the perimeter? 6, 7, 8, 9, plus another 6 is going to be 15, 16, 17, 18. And when the rectangles are 4, we got 6, 7, 8, 9, 10, plus 6 is 16, 17, 18, 19, 20. 20. So there's my table. Now, I want to do it write as words, write an equation, and write a graph. Let's do, doesn't matter which order, let's do a graph, because this is kind of like a table. So on the bottom, we're going to make this column, the rectangles column, I'm going to make this the bottom. So I'm going to label it rectangles. It's going to be the x-axis will be rectangles. On the y-axis, we'll call this perimeter. So we'll call this perimeter. I can't really write sideways on this. Usually I'd write that sideways, but I'm having a hard time. Anyways, so let's graph these points. Now, you got to be careful when you're plotting points, because you don't have to always just tick one at a time. On the bottom, I can make ticks one at a time. 2, 3, 4. But on the side, I don't want to start at 1 because I see my perimeter starts at 14 and goes to 20. So I may not want to start at 1. Okay, I might want to, and I might not want to count one at a time because if I did, it'll go 1, 2, 3, 4. It'd be way up here till I get to 20. So I got to start. Maybe I count up by 4 every time. So I'm going to count up 4 on this tick mark, 8, 12, 16, 20. So I'm scaling different. Now let's plot these points. When rectangles is 1, perimeter is 14. That should be about right here. Rectangles are 2, perimeter is 16. It's about right here. 3, it's 18. It's about right here. And 4, it's 20. It's going to be about right here. So these are these points that are plotted right here. That's another way to represent that. Now, let's say if I wanted to write an equation. Well, I have to label these variables. Let's call the rectangles, let's call these our x's, and the perimeters are y's. We've got to create an equation off of this. Maybe we did this a little bit the first start of the year. But what kind of pattern do I see here? Maybe before I do an equation, let's say this in words. Every time the rectangles goes up, this is going up by 1 every time, right? Plus 1, plus 1, plus 1. How much does the perimeter go up? Plus 2, plus 2, plus 2. So what I'm going to say is every time, let's see, rectangles goes up, the perimeter goes up by 2. So every time the rectangle goes up by 1, the perimeter goes up by 2. So let's create an equation of that. The perimeters are y. Then our rectangles, every time a rectangle is going to be our x. It's going up by 2 every time. So the number of y is going to be 2 times that x. But we also start with some number here. So there's also initial part. It's not just 2x. And to make that work, we'll have to make that 2x plus 12. Because there's an initial 12 here. You look at this first pattern here, it's 14. That's actually 2 times 1 plus 12. It's going to be 2 times 2 plus 12. We're going to play around with more of this week. You'll start getting it. So another thing about independent and dependent variables. Independent is the input, and we usually label this as x. And dependent variable is the output. We usually label this as y. One thing about the input and output, we use these when we want to talk about functions. What's a function? Every input, so every x value, has exactly one output or y value. So if you have an x, if I put an x into this, it only comes out with one y. So we sometimes write these function machines. So there's an input and it goes into the function and it shoots out one output and only one output. It's not going to shoot out 2 different numbers. So if I put in a 3 here, it's always going to shoot out some number of 5. It's not going to sometimes shoot out like a 2. It's always going to shoot out some number. So then let's talk about a special kind of functions, linear functions. These are when we graph a linear function, it actually looks like it forms a line. So how do you know if it forms a line? Well, you kind of look at it. So like this first case right here, I graphed memory versus number of photos. And I look at those dots and I can kind of see, yep, they kind of form a line that forms like that, so that's a linear function. Now, you're not always going to see a graph. Sometimes you'll see it as a table. So how do you know if this table is a linear function? Well, you see how the input is growing? The output has to change by the same amount every time the input goes up. So every time the input's going plus 1, plus 1, plus 1, right? Well, the output is this has to also just be growing by the same amount every time. Plus 2, 10 plus 12 is plus 2, and 12 to 14, that's also plus 2. So every time the input goes plus 1, the output's going plus 2. It's not like one time it's just going plus 3. It's always doing the same thing, so that makes it linear. All right, let's look at an example here. So pause the video if you want to try this out. All right, let's begin. So graphing our number of triangles, I'm going to call this my x variable, versus the perimeter, I'm going to call this the y variable. Okay, so the first shape, you just follow the pattern going on here. 1 triangle, 2, 3, and 4. So I'm going to make a table. I'm going to make an XY table. Actually, let's not. Let's just label it triangles and perimeter. Be consistent with what we did before. So triangles versus perimeter. So when you're graphing triangles per perimeter, when I have one triangle, what's my total perimeter? 3 plus 3 plus 4 is going to be 10. When I have two triangles, what's my perimeter? Well, it's 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. When I have three triangles, what's my perimeter? Well, it's going to be 3, 4, 7, 10, 18. And when I have four triangles, what's my perimeter? Well, 7, 11, 14, 18, 22. 22. So there's my table. Now I want to graph this. So I'm going to put my x-axis going to be my triangles. I'm going to label that triangles. And on my y-axis is going to be perimeter. So I'm going to label this, let me just call it perimeter. All right. So I'm going to count this triangles up as 1, 2, 3, and 4 on my graph. And then, well, how much am I going up each time? I want to be careful with how I scale this again. Let's go up by 4 every time. So 4, 8, 12, 16, 20, 24, 28. So let's plot these points. The first point at 110, so 10 is going to be about right here. Second point at 214, 214 is going to be about right here. This next one is 318, 318 is going to be right here. And 422 is going to be about right here. It's good when we do these to label these points too, so I know what those actually are. Sometimes it's hard to just eyeball that. So let's label this 318, and I'm going to label this 214, and label this 110. Okay, so how do I want to explain what's going on in words? So the perimeter, every time we grow the triangle, looks like it's going up by 4 every time. Plus 4, plus 4. These are always plus 1, plus 1, plus 1. So in words, I'm going to say every time you add a triangle, I'm going to draw a shape, the perimeter goes up by 4. Okay, so I know that's going up by 4. Maybe I say something about the initial perimeter. So I can say that one triangle starts with a perimeter of 10. I'm going to say one triangle starts with a perimeter of 10. So what's an equation for this? Well, let's say if I make my triangles my x and my perimeter my y. So my perimeter is my total. I come out. That's our dependent. It's our output. So in our triangle is what we put the input. So an x in here. And since the perimeter is going up by 4 every time, we do a 4 times that x. And what is our initial amount going to be? Well, you have to take away that 4 from the 10. So it's going to be plus 6. So this is the equation that'll work for this graph. And it'll work for these points right here. Right. Try one more. All right. Is this a linear function? Explain it. Well, I want to see if I'm going up. Oops, this should have been 2. Oh, no, that shouldn't have been 2. Okay, so let's see if this is a linear function. I went up by 1, I went up by 2, I went up by 1. Huh? That's weird. I'm going up by 2, going up by 1, and then going up by 3. No, that's not. It's because, why is this not? Because it's not growing at the same rate every time. As x is jumping, not jumping one at a time, and y is changing all over the place. It's going only up 1 this time, and only up 3 this time, only up 2 this time. It's not consistent at all, so it's not a linear function. And if you actually plotted that, you wouldn't be able to draw a straight line through those points. That's it.